Problem 31, end of chapter 3. You're driving your car with a velocity of 20 meters per second north. This vector right here represents that. Approaching an intersection. Here's the intersection. Another car approaches the intersection with a velocity of 25 meters per second west. This is the other car. We're first supposed to find the velocity of the other car relative to you. Well, in your reference frame, you were at rest, and so to find the velocity of anything relative to you, you subtract your velocity from that other object. And so to find the velocity of C relative to me, I'm going to take the velocity of C and I'm going to subtract my velocity. That's what I've done here. Here is the velocity of C, 25 meters per second west, and here is minus V sub me, 20 meters per second going south. And so here is the velocity of C relative to me. The magnitude of that can be calculated from the Pythagorean theorem. I have an x component and a y component which goes underneath the square root and yields 32 meters per second. In similar fashion, the angle, in this case south of west, can be found by the inverse tangent of my velocity versus the other car's velocity, 20 over 25, 38.7 south of west. So that answers the first part A. Part B, if you imagine yourself to be at the origin and the other car is 100 meters to the east of you and 100 meters north of you right here, then you will see the path of the car being V of C relative to me. That's this vector which we've already calculated, and the speed of that you observe, the other car will have is 32 meters per second, and it will have, as we've already calculated, 38.7 degrees south of west. That would be this angle right here.